In this video, I will walk you through free response question number 4 from the 2007 Form B AP Calculus exam. Let f be a function defined on the closed interval from -5 to +5, with f of 1 equal to 3. The graph of f prime, the derivative of f, consists of two semicircles and two line segments as shown above. Part A. For the interval from -5 to +5, find all x values for which f has a relative maximum. Justify your answer. The steps for finding a relative maximum are: number 1, find the critical values, and step 2, make a sign chart. The critical values of f are the x values which either cause f prime to equal 0 or to be undefined. Looking at the graph of f prime, we don't see any discontinuities. There are no asymptotes, there are no holes. In other words, f prime is defined everywhere, so we don't have to worry about where f prime is undefined. So where is f prime equal to 0? Remember, we are looking at the graph of f prime, so we simply need to see where the graph touches the x-axis. So we have these four critical values. Okay, so we have the critical values. Now it's time to make the sign chart. Since they gave us the graph of f prime, we can easily make the sign chart right on this graph. At -5, the graph begins. So to the left of -5, we don't really know what was happening. I'm just going to put a question mark there. But after -5, the graph is above the x-axis, so it goes from question mark to positive. Let's look at the critical value of -3. To the left of -3, f prime is above the x-axis, f prime is positive. To the right of -3, it becomes negative. So we go from positive to negative at x equals -3. Let's jump over to x equals 1. To the left, f prime is negative, below the x-axis. To the right, it is positive, above the x-axis. Okay, let's jump over to x value of 4. To the left, f prime is positive. To the right, f prime is negative. Think about the graphical relationship between f and f prime. At a relative maximum, the original function f goes from increasing to decreasing. If the function is increasing, then f prime will be positive. If the function is decreasing, f prime will be negative. So, at a relative maximum, f prime should go from positive to negative. Looking back at our sign chart, we see that f prime goes from positive to negative at an x value of -3, and it goes from positive to negative at x equals 4. What about the question mark? Well, we don't know what the question mark is, but it goes from something to positive. So it definitely does not go from positive to negative. So we can disregard the -5. Here's our summary statement and justification. f of x has a relative max at x equals -3 and x equals 4 because f prime changes from positive to negative at x equals -3 and x equals -4. Part B. On the open interval from -5 to +5, find all values of x at which the graph of f has a point of inflection. Justify your answer. A point of inflection occurs when f double prime changes signs. However, for this problem, we are given the graph of f prime. We don't have the graph of f double prime. As we think about the graphical relationship between f prime and f double prime, we realize that if f double prime changes signs, then f prime will change either from increasing to decreasing or from decreasing to increasing. So let's look back at our graph of f prime and see where it changes from increasing to decreasing or vice versa. Notice that f prime goes from increasing to decreasing at x equals -4. So that's a point of inflection. F prime changes from decreasing to increasing at x equals -1, another point of inflection. Finally, notice that f prime goes from increasing to decreasing at x equals 2, a third point of inflection. Let's summarize and justify. F has a point of inflection at x equals -4 and x equals 2 because f prime changes from increasing to decreasing at x equals -4 and x equals 2. F has a point of inflection at x equals -1 because f prime changes from decreasing to increasing at x equals -1. Part C. Find all intervals on which the graph of f is concave up and also has a positive slope. Explain your reasoning. First of all, a positive slope means that f would be increasing. So we need to find all intervals on which f is concave up and increasing. We need to translate this information into a description of f prime, since that's the graph that we have. So if f is concave up, that means f prime will be increasing. If f is increasing, that means f prime is positive. So as we look at the graph of f prime, we need to see where f prime is increasing and positive. F prime is positive for these parts of the graph because it is above the x-axis. Out of these red sections, the purple parts show where f prime is increasing. So f prime is positive and increasing from -5 to -4 and from 1 to 2. Time to summarize and justify. F is concave up and has a positive slope on the intervals from -5 to -4 and 1 to 2 because f prime is increasing and positive on these intervals. Part D. Find the absolute minimum value of f of x over the closed interval from -5 to +5. Explain your reasoning. The absolute minimum will either be a relative minimum or an endpoint. Remember that at a relative minimum, the function will go from decreasing to increasing, which means that f prime will go from negative to positive. Remember that this is the graph of f prime. So x equals 1 is the only location where f prime goes from negative to positive. It goes from below the x-axis to above. So this is the only location of a relative minimum, and the endpoints are -5 and +5. So these are the candidates. Here's what we write for the AP graders. X equals 1 is a candidate for absolute min because f prime changes from negative to positive. X equals -5 and x equals +5 are candidates for absolute min because they are the endpoints. Here are some notes that you will need to solve the rest of this problem. The area between f prime and the x-axis from a to b is the change in f from a to b. For example, this yellow area represents the change in f from -5 to -3. If the area is above the x-axis, it is positive. That means the value of f increases from -5 to -3. If the area is below the x-axis, it is negative. So the value of f decreases from -3 to +1. Here's the other thing you need to know. The change in f from a to b is the integral of f prime from a to b. If we pick -5 as the starting value and +1 as the ending value, we should be able to build an equation relating the starting value, the ending value, and the change in between. Let's start with the value of f at -5. If we then add the change in f from -5 to 1, this should equal the value of f at 1. This makes sense if you think about it for a minute. The value at the beginning plus the change should equal the value at the end. But remember that the change in f from a to b is the integral of f prime from a to b. So the change in f from -5 to 1 should be the integral of f prime from -5 to 1. So now we have this equation. Let's go ahead and copy this into our work below. So here it is. Let me explain why I picked -5 as my starting point and +1 as my end point. I have these three candidates, x equals 1, x equals -5, and x equals +5. I need to find the value of f at each one of these so I can see which one is the minimum. So I picked x equals -5 as my starting point because I'm hoping to use this equation to find the value of f at -5. Why did I pick f at 1? We are given the value of f at 1 in the original setup of the problem. F at 1 is 3. Since f at 1 is 3, I can make that substitution. So if I want to find f at -5, all I need now is the value of this integral. But don't forget that the integral of f prime from -5 to 1 is the area between f prime and the x-axis, between -5 and 1. So we have this positive area and this negative area. They're both semicircles. So we know the area of a circle is pi r squared. So for a semicircle, we have half of that. The radius of this positive semicircle is 1. So we have 1/2 pi 1 squared, which is just 1/2 pi. So that's the first area, 1/2 pi. What about the second area? Another semicircle, so 1/2 pi r squared. The radius in this case is 2. So this is 1/2 pi times 4. Half of 4 is 2. So that makes 2 pi. But wait a minute. This is a negative area. So instead of putting a plus 2 pi, I should put minus 2 pi. So this is the value of the integral of f prime from -5 to 1. Substituting the value that we just found for the integral of f prime from -5 to 1, we have this. Well, actually, these are like terms. So let's go ahead and combine these. 1/2 minus 2 is -3/2. So now we have this. Remember, we are trying to find f at -5. So let's get this by itself by adding 3/2 pi to both sides. Kabam! Let's see if we can set up a similar equation that will allow us to find the value of f at x equals 5. So what will be our starting value and our ending value? If we want to find the value at x equals 5, then that's going to be our ending value. We will pick x equals 1 as our starting value because that's a value that we know. As you set up your equation, you should be thinking the beginning value plus the change should equal the end value. But the change in f from 1 to 5 is the integral of f prime from 1 to 5. Let's evaluate this integral by calculating the area between f prime and the x-axis between 1 and 5. So we have this yellow triangle above the x-axis. The area of a triangle is 1/2 base times height. The base is 3, and the height is 2. So that is 3, and because the area is above the x-axis, the area is +3. Let's go ahead and include that in our calculation. And now the area of the small blue triangle. Again, 1/2 base times height, but the base and height are both 1. So this is just going to be 1/2. However, because this area is below the x-axis, it is a negative area. So we will actually subtract 1/2 in our calculation. We already know that f at 1 is equal to 3, so let's go ahead and make that substitution. So we have 3 plus 3 minus 1/2 is equal to f of 5. So let's see, this is 6 minus 1/2, so that's 5.5, which is the same thing as 9/2. Let's wrap this up. In the beginning, we found three candidates, which were possible locations of the absolute minimum: x equals 1, x equals -5, and x equals +5. We did our calculations and we found that f at -5 is 3 plus 3 over 2 pi. F at 5 is 9/2, which equals 5.5. And in the setup of the problem, we were given that f at 1 is equal to 3. So which one of these is the absolute minimum? Well, 3 is clearly less than 3 plus 3/2 pi. And 3 is obviously less than 5.5. Therefore, f at 1, which equals 3, is the absolute minimum. In summary, f of x has an absolute minimum at x equals 1. The absolute minimum of f of x is f of 1, which equals 3.